needed only 4.
Bro, well, okay, this was
Perfect.
in with stack and heap.
Right.
This
okay,
is
that's fine.
this is the same slideshow we've been going on
Okay,
for
then.
like the last 3 weeks, but we finally gotten to the end half.
All right. Well,
All right, so inheritance. Let's talk about what inheritance
Inheritance.
is. I'm gonna just turn Spotify down just a little bit because it's a little loud for me, which probably means it's a little loud for y'all. Okay. What is inheritance? It's a concept found specifically in object-oriented programming. So you're not going to go find it in your normal Python when you're not using object-oriented and that kind of stuff. Rabbit hole. The first review session is on YouTube, and from like whatever's on Twitch onwards will also be on YouTube. We had like a 2-week period where we didn't have review sessions on YouTube, and they're now lost.
But we will.
They're now lost to the void.
Yeah.
But there
That's a
will
little bit of
the
a
first or second one are on YouTube, and whatever's on Twitch and from this point on will be on YouTube. Okay, so inheritance allows programmers to create classes with generic methods and variables. So it lets us make basically a template for some other classes that we're going to write. So that way we can fill in our stuff later. Rabbit hole, if you go to Jesse's website, which is CSE116.com, the YouTube channel is right on there. So other classes are able to extend this template class that we make and get all of those variables and methods that we have in there. There's generic methods and generic variables. And we call this template class, once it's extended by another class, the super class. It's the one above. Now this allows us to make generic methods, right, that are specific, that you can then specify in a specific class. And if you don't understand that, we're going to go into an example, I think. I'm pretty sure. Yeah,
Also,
we are.
Before we continue, I know in Nazrin's section she called it a parent class. Parent and superclass are the same idea. Do not confuse the two.
Yep.
I hope that doesn't confuse you because they're both the same thing. We just call them different names sometimes.
All right. So
Sometimes it's mom and dad.
when we make a class that's going to be inherited by something else, you generally have it as an abstract class. So this is going to be like the root of our templates, right? This is going to be our superclass for any type of ball that we make, and you'll see that in a minute. So our abstract class is very generic things. It's got a length, a diameter, a weight, a name, which are all zeroed out or nulled out, that kind of stuff. A random, which if you don't know what random is, it's a Scala library that we can use to make random numbers, and it has the beginnings of a method called throw ball, which returns a string, but it has nothing in it. We just say that there is a method that you need to implement in any subclass of this called throw ball. Does anyone have any questions on this generic class right now before we continue on? Why did my Spotify just stop?
You know, I saw it go away.
I saw it go away
changing
too,
songs.
and then yeah, so did I. You don't use to define types. You definitely can define types. Scala is, for all intents and purposes, Scala is a strongly typed language, and which means you have to define types. But it's strongly typed in the fact that it doesn't also really care. That sounds confusing, but like, it is strongly typed. You should be putting those. I didn't. It will still work.
You should definitely be.
You should definitely be putting the types. But I made this 3 years ago, so it cut me like half a minute of slack. This was literally 2019. Do we just type abstract? No, you would put the actual variable. So var length would be a double, and then that. So classes are blueprints for objects. Inheritance is like a blueprint for other classes. Yes. I'm gonna say with yes. I'm not even gonna say yes. Kind of.
It's like
abstract
that's
classes.
basically the same idea.
Inheritance is the concept that says that this class is a blueprint for another class. The actual, like, if you think about it that way, the analogy of like classes are to objects, it's as abstract classes are to regular classes. That's the actual analogy that you'll kind of get.
Yep.
So ball is a generic class, right? That's what we talked about. So obviously I made arrows, but I didn't write what they were for. Okay. So this one on the left, this one over yonder, is basically saying that these are our generic variables inside of here, and this one is our generic method. That doesn't have anything in the method itself. It's just saying there's a method here. Okay. So now we have football and baseball. So this over here on the right is our ball class that we had before, right? From the last slide. Now on the left side we've got football and baseball, which are types of balls, right? And here we get to basically re-say what these values would be. So in over here, we said name was an empty string. Well, in football, the name is actually going to be football, right? We put the correct weight in, the correct diameter, the correct length. Now, if Jacob was here, he'd want me to actually very much say that he spent about 20 minutes figuring out the exact weight of baseballs and footballs to put the correct numbers in here. He spends 10 minutes on it every single time we do this lecture, but I'm not going to. But the important part that I want to get to here, right? We've extended the class, which means we have these variables, name, weight, diameter, and length, that have already been declared somewhere else, which is here in this superclass. The important part here is this word here that says override. This throw ball method that we have here in this abstract class doesn't have anything on it. If you were to call throw ball, it wouldn't work. It wouldn't do anything. Here, we're making it do something, but instead of just setting it equal to, we need to redefine it by saying override. We want to override whatever the definition of it in the superclass was. So we're overriding the definition of throw ball, which returns a string, and is now going to be this, which says that we have a list with spiral, lob, bullet, and Hail Mary in it, and we're going to choose a random one from the list, is what that says. So the same thing for baseball. We override those name, weight, diameter, and length variables, and then we override the meaning of throw ball in this class by saying that it's going to take a random one from the list of curveball, screwball, fastball, and slider. So I think we have... Yes. So we're going to create our own extension from ball. And again, these worked way better when we were in person. We're actually... let me answer inherited class question, and then we're going to go back to this. The difference between an abstract class and a regular class. The ones on the left are regular classes. The one on the right are abstract classes. The big difference is you cannot instantiate an abstract class. You can't make an object ball. You have to make an object football or an object baseball, or like we'll see in the next slide, an object basketball, but you can't make an object ball. It's a generic class. It's abstract. It doesn't have substance in itself, right? Like very much, well, showing this is our throw ball method here. It doesn't do anything. So we make these templates, these generic classes here. These are our templates to make more substantive classes like these over here. So an abstract class is the same thing as a superclass. Yes. And that's right here,
that's the idea.
Where we say class football extends ball, this is saying that our class football is inheriting stuff from ball. That's where inheritance comes from. We're inheriting the stuff that's inside of ball. So let's make our own version of ball, our own extension of ball. So we have a basketball, which inherits everything from ball. We know these facts about it, which is it's spherical, it's got diameter, it weighs 623 grams. You can do all of these things. So how would this look as a class? So I'm going to take a couple minutes to answer some questions. Whoever wants to, open up IntelliJ, open up Notepad, open up... If you really want to do it in a Word, I don't really care. Open whatever text editor you have, and think about what you want to go into here, and think about kind of how you want to do it. I'm going to go back a slide. I'm going to go back a slide after I type this in.
Definitely go back a slide after you type everything in. Okay, so MJ Cruz, when overriding a state variable, you don't rewrite the var part. No, because you are taking the variables from the abstract class.
Correct. So I'm going to go over that for a second.
You do not need the var.
So what I just threw in the chat is the statistics kind of stuff that you need to make your own class if you want to. So, yeah, what Leo just said about overriding that variable. Let's say you were in one piece of code, right? Let's say you were in a method X, right? And you had a variable in there Y, and you went to reassign Y. You wouldn't write var Y again. You just write Y, because you're accessing the same variable that was previous. You're in here. You're accessing these variables that are in here. This version of these variables. So I'm going to give you guys
to change their values.
Exactly. Change their values in this specific class.
In this specific class, yes.
So I'm going to give you guys about a minute and a half, 2 minutes maybe, to start thinking about what you guys kind of want to have in basketball. And then we'll go and show the basketball code that I've got from whatever ago. What was the last line? The list random dot next int. Basically it says I'm going to access a random index in the list that is within the integer range of the list length. Basically, it's choosing a random string from the list. I don't know why Jacob decided to make it confusing, but he did.
We really could have just chosen anything in that list.
Yeah.
It didn't need to be random.
Well, no, I understand the random, but like that's a confusing way
understand
to
the
do
random,
random.
Yeah.
Or you didn't
Yeah.
have to do random. You could have just looped through the list.
Why not? Yeah.
Here, it literally chooses something random. That's all I get it now.
Yep. Basically.
All right, so I'm gonna hop forward now to our actual class basketball. So, does this look right to everybody?
Is this what everybody got? And you can even see it because the tiniest thing on the slide. Could make it bigger, Logan. All that extra white space on the slide.
Don't at me, man. Wait, why is there literally...
Wait, what? There's...
Oh, wait, there might be stuff there. There might actually be a reason there. There might be a reason why that stuff is there.
Okay. Is this what everybody got for their basketball class? I got sugar bombs.
Oh no, there's literally no reason why that stuff was there. I don't know why there was a bunch of white stuff there. That's
just
great.
A random white
There's
rectangles.
just some random white like boxes at the bottom. All right, let's just
Okay. All right. Well, let's just
So
Yep.
So if this makes sense to everyone, that's good. This is the concept of inheritance. This is saying that this class basketball is inheriting ball, which is a really powerful concept when you end up doing object-oriented languages. It's going to especially come in concept when you guys do state machines for Jesse's class point of sale, for Nazar's class calculator and microwave. Because you guys will be making a generic state and then making specified states off that generic state that inherit those generic states. Speaking of polymorphism, which I didn't say at all, I'd like to make that very clear. I did not say polymorphism when I talked about states. Hint. Let's go talk about polymorphism. Maybe. If I can find the lecture on polymorphism. I don't have one. I definitely don't have one.
Yeah, I was thinking about it. I was like, I do not.
No, because like these go in time order for the most part. Kind of, because this is WebSockets. It's in a weird order, but like.
Right.
Yeah.
Okay.
All right, so we're gonna go steal Jesse's slides because I'm lazy.
Yep. Jesse, sorry, we're stealing your slides. But
Oh, he knows I steal these slides all the time. we're gonna go through them a little bit slower, and I'm gonna speak a little bit more about different things in here that I think are important than Jesse kind of generally does. All right, so this is an important chart. You don't need to understand everything on this chart, but this is an important chart. There's this magical data type in Scala called any. Don't use it. Unless we tell you to use it, don't use it. There's this.
Please don't use it.
And then this data type any here inherits these two different other data types. Now that we learned this word inherits, I'm going to talk about it a lot. Null is over here. Null is.
Null, I think, is at all the way at the bottom by any ref. So
nothing and null, which are two different things.
We will go into that.
Yes. So any ref does stuff with objects, any val does stuff with values that we have. So all of these normal values that we talk about all the time, so ints, floats, doubles, boolean, chars, bytes, and importantly, unit, all are inheriting any val. Can you store your class in null? No.
I would, yeah.
So all objects share any as their base type, and then anything that has any val, so anything that's over here, is stored on the stack. Anything that does any ref is stored in the heap, which is what we've talked about with making your classes and your objects and your lists, and all that stuff gets stored in any ref. So we're going to skip past this, because I just really don't care. Basically, if you make your own class, it goes on the heap and it's under any ref. So we're going to talk about polymorphism for a second. So polymorphism is a super fun word to say. Let's start there. So the word polymorphism says it's many forms. That's what polymorphism means. So basically it says, let's go here. Let's go actually back to this recall. We have a physics object that inside of it has a location, which is a physics vector. Our game object that we have inherits our physics object. So this location here gets inherited from this physics object. We have this object mass and a method that does a use with a player that returns a unit, and a method that says whether a player is close to this game object that returns a Boolean. Our dodgeball is a game object. Our health potion is also a game object. So this is how this gets inherited. I'm actually going to duplicate this tab.
Yes.
And do some dual screen action here.
Dual screen. Oh my gosh. Wow.
Just because technically advanced review sessions. Because it might help to have this little chart up
while we go through polymorphism. It'll help you guys a lot more in understanding what's going on.
So when we go here, right here we have health potion, which is a new health potion. This is how we normally write our methods, right? We have a health potion that in it has a volume with an integer, but a health potion, so it takes in a physics vector inside of it and this other thing. Okay? This object mass, I think it is. But then down here we have a game object. And we can also say that a health potion is a game object. And we can also say that our health potion is a physics object. And our health potion is an any ref, and our health potion is any. And why can we do this? And this is the thing of polymorphism. Polymorphism says that if whatever class I'm in inherits another class, we can actually say it's that more generic class. So I can make this this variable potion 2, which is stored in a game object, and I could say new health potion here, and I can then later reassign potion 2, which we know is a game object, to be a dodgeball, and that's totally kosher, because it's a game object, and both of these classes inherit game objects. I'm going to stop there for a second, because that's a big concept. And I don't want to continue on much further unless people understand it. We're going to continue on, though. But just I want to hold on for a minute.
Do you guys have any questions about that?
How can we reassign values? These classes work exactly the same as inherited classes. Polymorphism is just saying that if we have this overarching class, we can go back to the... Actually, let's go back to our basketballs here. Okay, we're going to write in the speaker notes because I'm lazy. Okay, so let's say I have var A, which is a basketball, right, equals new basketball. Now, I'm not going to fully write that because I'm lazy. And we've got var C, which is a baseball, which is equal to a new baseball, right? We know, because we've gone through these slides already, we know that basketball extends the ball class. We also know from here that baseball extends the ball class. So what we're able to do here is, let's say we've got var lob, which stands for list of balls, is a list of type of ball. Okay? This can be equal to a list of A, comma C, because basketball is a type of ball and baseball is a type of ball. We can make a more generic overview that we can then put more specific things in. This was a pause. This was a pause for making sure everybody understood. Sorry. I know I didn't make that very clear that this was a pause for understanding.
Okay. It's okay. You went full quiet mode.
You put your var, but it can also be val, right? Yes, it can totally be val. That's...
It can definitely be a val.
Yeah. I instinctually put var always, constantly. Just know that. Polymorphism or in the previous var. No. No. Polymorphism says that when your class inherits something, so when your class basketball inherits a ball, it is not only a basketball. Like, let's say when I make this new object A, it's not only a basketball. It's also a ball. It's also an any ref. And it's also an any. Because it inherits all of those classes. It's a little bit of a confusing concept, which is why we're going over it here. I would like to know how to inherit a big estate. frosted mini wheats. How does it work? Like, how does the code read? Literally like this.
That's
This
exactly
is literally
how
how it works. What are any ref and any? Rafi Khanum, I will get back to you in a second. Let's make sure Jack understands how the code reads, because I'm going to have to move away from this to answer that question.
Yeah, so Jack, this is literally how the code reads, always. Yeah. And each one will store a reference in the heap.
Can you explain how lines of code on Jesse's slide compare to this code? Yes, absolutely. And we'll go back to here. So remember up here, we said that a health potion inherits game object and game object inherits physics object. Let's start with that. So health potion inherits game object, which inherits physics object. That means that every health potion we make is a game object, and that every game object that we make is a physics object, because they inherit each other. So down here, that then allows us to say that not only when we create a new health potion, it's a health potion, it's also a game object, and it's also a physics object.
It can be both.
And because of this chart here, this type hierarchy, we know that your class, which is whatever classes that we make, they all automatically inherit any ref, which automatically inherits any. So we're able to also store that health potion in any ref and store that in any. So the health potion contains all the variables stored in the objects it inherited.
Yes.
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 No.
The health potion contains all the variables.
Yes. Yes. Yes to the health potion. Yes. Okay. Yes to the health potion contains all the variables stored in the objects inherited. Yes, that's correct. That is not polymorphism. That's inheritance. Polymorphism says that when we have a health potion, it can also be classified under being a game object or being classified under being a physics object. How is this then used in code? Just like I said. Let's say you're a phys ed teacher, right? And you wanna, this is the weirdest example I've ever come up with, by the way. I'd like to state this ahead of time. You're a phys ed teacher, right? And you're taking inventory of all of the balls you have in your ball cage, right? And you got basketballs in there, you got footballs in there, you got baseballs in there, you got every type of ball in there, right? We have this generic class ball, and we're saying in this list we want to store all those balls that are in the cage. So we're going to store all the balls that are in the cage. Because basketball and baseball are specific types of balls, we can just say that they are generally balls. Right? You can have another example is sport, right? We can have a generic class called sport, but then we have more specific versions of a sport, right? We have basketball, we have baseball, we have football, we have hockey, right? We have those very specific types, but they're all classified under the giant umbrella, as I do the umbrella with my hands, yeah, of sports.
It's a very big topic, though.
So when creating Val Potion 1, which of these 6 classes should we identify it as? Health Potion, Game Object, etc. Depends on your code.
It depends on what the
What Swimmer says is exactly correct. So inheritance is taking all the variables and the stuff from the stuff before it, and polymorphism is being able to call whatever object you've just made as anything that inherits it.
Yep. That's the best example.
That is dead correct.
Yeah.
So if you think of it as like downstream and upstream, inheritance is pulling everything from above you, and polymorphism is saying everything below this point is this. It's polymorphism's kind of like an umbrella. If you say everything if you say basketball and baseball and football all fall under the umbrella of sports, that means that you can classify all of them as sports. You don't have to always classify baseball as baseball. You can say baseball is a sport. I hope that makes sense. How come you have basketball equals new basketball, but that's not the same as just a slide? What?
We just made our own.
I made this own class.
We're just making our own. We made our own basketball class.
Yeah, I made my own basketball class, and I was too lazy to fill in all the parameters. We've got 2 slightly different examples going on here, right? So
Yeah.
I've declared, just like in the first line here, where you declare this as what it actually is, right? You've declared health potion as a health potion. Here, I declared basketball as a basketball and baseball as a baseball, right? But here, I've said that that's another good example repetition. I'll get to that in a second. I've said that we have a list of ball, which both basketball and baseball fall under, which is how we can use game object and physics object. So what repetition said, I'm going to expand on that a little bit. So if you think about like Pokemon, right? You can have this generic Pokemon class that says that you have... I love the laughing Leo, because I definitely used this last semester too, and I totally forgot about it.
You did. You used it in the lab.
Oh.
I remember this.
Oh yeah, and then I also used like armor and stuff, because I couldn't think about anything.
Yes.
I used Minecraft swords, that's what it was.
Yes.
You can tell which labs
exactly.
I write based on what goes in that.
Exactly.
So you've got Pokemon, right? You've got this generic Pokemon, right? So you say that every Pokemon ever has health, HP, it's got 1 to 4 moves, it's got a type, right? And when you make a specific Pokemon, it inherits those values. So you're saying that every Pokemon, when you make a specific one, so like let's say you make Turtwig, right? It's gonna have a type, which is grass. It's gonna have some moves, like it'll have like Leaf Blade or whatever, right? And it's gonna have some HP, right? But you could also say, when you've got a team of Pokemon, right? Let's say you have Turtwig and Charmander and Piplup, right? Which is totally different types. They're totally different Pokemon, right? I will get to you in a second, Jack Sparrow. Which are totally different Pokemon. You can classify all of them overarchingly as Pokemon. So when you have a list of Pokemon, any Pokemon can go in there. So I can... Let me rewrite my slide to act a little bit more like what you're looking at on Jesse's slide.
Just for the reference of Leanna, oh my god, Polymorphism is like that Pokemon that can evolve into multiple things. That's Ditto.
So
get his name correct.
So Jack Sparrow, this is what we were just saying. Is that you can declare any basketball as a basketball, but you can also declare it as a ball. Which means that when we make a list of balls, just like we have here, that both A and C can go in there, even though C is declared as a ball and A is declared as a basketball, A inherits that ball quality, so it can be like it's under the umbrella of ball. Okay, we got it in full caps. I'm feeling better now.
Yeah, I feel way better.
I like it when it's in all caps. I made a post about Rengar and Piazza with Inheritance not that long ago. I assume Rengar's a Pokemon in this situation. I haven't played in a while. Can they only be used in lists? No,
Wait,
if you've got a map, like let's say like var name of ball is a map that does ball to name. Please forgive me if I don't write correct Scala. Pseudo. Oh, okay. The League Rengar. That's fine. Understood that one. We were talking about Pokemon, so I assumed we were still on that track.
I was so confused for a second.
Yeah.
I was like, you know, Rengar? So confused for a second. It's okay. It happens.
So it's like these are like manufacturers, right? That should be a comma.
Jack Sparrow, no, they cannot only be used in lists. They can be used in a multitude of other things.
Yeah, so for example, here's a map that I use ball to name in, where we're talking about the manufacturer of a ball. That A is made by Spalding and C is made by Wilson, but they're both ball, so they can both be put there. That it's not specifically just a basketball that can put there. Any type of ball can be put there.
Your syntax is quite impressive.
I can't tell if you mean that in a serious way or a joking way.
No, it's completely wrong.
Oh yeah. Anytime I write,
okay.
full disclosure, anytime I write code here, it's always pseudocode. unless I'm
Yeah.
in IntelliJ actually writing code. It's always pseudocode. Because I can guarantee that at any given moment, the last language I've written is not Scala. It's probably Python, so I end up mixing Python with Scala all the time.
Summer239, what is your favorite Pokemon? To be quite honest, I don't have a favorite Pokemon. I like them all, but it's okay.
Python's greater than Scala.
In certain aspects, yes, I would say. I think it depends. I personally think it depends.
So apparently somebody just dropped food off at my house, which confuses me.
Funny thing. So I actually have from last review session, I have a habit of playing with things, and this is the aftermath of a plastic fork that I got from a restaurant to eat my food.
Hold on. There we go.
So I'm gonna bring it closer so you guys can see. This is the remnant of a plastic fork that I just used to eat my food last night with.
Hold on, we're gonna make this even bigger. I got it.
Logan, you're out of focus.
Oh, I'm always out of focus, man. It's constant. Here we go. There you go.
Alright. The remnants of my fork. Hope you guys enjoyed. I completely ripped this apart, by the way, with my bare hands, actually. I hope you guys enjoyed that.
You miss Python?
Scala, I feel like Scala is overcomplicated a lot of the times. I miss Python.
You don't trust me. You don't miss the days of Python and Replit. Trust me, you don't.
You guys. I wish you guys understood what Python really is outside of Replit.
Yo, you ready? You ready for this? I'm about to blow everybody's mind. Python is an object-oriented language, and none of you have used it that way.
Boom.
You can make objects in Python.
Python might not be so strict about it, but you can.
And you do a lot.
And you do a lot.
Bro, Google it. Swear to God. Alright, we've gotten to the end of our planned stuff, because apparently in 40 minutes we can explain inheritance and polymorphism and everybody understands it, because we're really good at life.
If you guys have any other questions about it,
shut up, Google!
You could definitely answer. You could answer? We're answering your questions. You guys should definitely
ask. Yes, you will use Scala in other classes. You'll use it in 250. And then you can use it in like random other classes. Like I could have chosen to use it in 312. I chose to use Python. Can you summarize polymorphism just one last time? Yes. Leo, are you frozen smiling, or are you just like... Oh no. I think Leo died. No, like he's real dead. Hold up, I'm totally gonna take a screenshot of this and meme this because I legally have to. We're gonna have some live memeing on the stream. We did a live meme last year, so I think we have to do a live meme again this year. I think I'm legally required to show the meme from last year, so I'm finding it. Okay, here we go. I want this. Oh, and Leo has left the Discord call. Okay. Oh, he's back in the Discord call.
I'm back.
You get there, buddy?
I funny thing actually. Funny thing actually. So I actually so the power the what's it called? The surge protector is right at the bottom of my foot.
Did you hit?
If I tap it lightly with my foot, my whole computer like resets itself. I have no idea why, but it happened.
That's hilarious.
What's I see that
This beautiful
Wait,
meme.
that you included the meme of 116 students. Is this a debugger? So,
Oh,
if,
Leo. I've
Yes.
got Photoshop open. I'm ready to go.
let's wait. About what? What just happened? Let me actually turn on my camera here.
I'm pretty sure I'm legally required.
Alright. Oh my gosh. Speedrun making meme.
There's no speedrun required, man.
That looks amazing.
It's close enough. There you go.
I like it.
I don't even think I need to do anything. I think I could just leave it like this and it'll be fine.
I think you should just. I think you really could though.
Alright, let me make you bigger again so that way this works correctly. Where's Photoshop? There it is. There's OBS. Okay. All right.
Just
So
make myself
let's do a really quick polymorphism comparison really quickly before I go into Leo looking like that. The quick explanation of polymorphism is the umbrella example. So let's say you have a bunch of things that are the same, roughly. So let's say you've got phones, right? You've got your Android phones, you got your Apple phones, you got like 17 different types of Android phones. You got the Firefox phone, you got that one weird Linux phone that released, right? You got your old standard flip phone, you got all that stuff. They're all phones, right? So they all inherit this general phone class. But we can refer to all of them as phones. We don't need to refer to them specifically as a phone. Like, you don't need to refer to this specifically as Logan's Android phone. You can refer to it as just a phone. It falls under the umbrella of a phone. So polymorphism is saying that all phones are phones, regardless of how specific we are about what phone it is. Regardless if we're talking about, this is Logan Ramhap's Samsung Galaxy Note 25G. If we say that versus if we say this phone, it means the same thing. They all fall under the umbrella of phone.
I also would like to mention from Jack Sparrow, I still don't understand how polymorphism is used and called and incorporated into code. So, I don't know if you guys still have lecture questions, Logan, but the lecture questions
We have lecture
were
tasks.
definitely right. Forgot about that. And so you're gonna see that a lot in the questions that you get after lecture, and especially when we start talking about state pattern. We're not gonna talk about state pattern yet, but you're going to see a lot of polymorphism and inheritance happening when we go into state pattern.
Yes.
It's almost like we use polymorphism in our everyday lives. Yeah. But maybe not really, but yes. Samsung over Apple. Oh, I'm more of an Apple guy.
It doesn't matter, regardless.
Yeah. When you extend a class, do you do it within the class or in a separate Scala file? When you're making new classes, you should make them always new files, always new Scala class files.
Yep.
Always. Don't try to do anything within the class. How dare you, Logan?
Don't worry about it. I put them all together one way. You definitely can put them all together, but like, don't. Just for ease of use, make like a folder called like classes and put all your classes in there. You'll have a much better time later on.
Yes. it keeps things way more organized and everything. Because starting to put them in the same file starts to get a little bit more confusing for your end.
I'm just jamming out here.
Yeah, I can tell. Just jamming out. Are you listening to the one that's put on the stream?
Yeah. If you have Spotify, right? If you go into Discord, I was gonna say, if you go into Discord and you like hover over the channel we're in, you can actually join the listening party, so you hear the same stuff that I hear at the same time.
Wow.
Yeah.
So
if you're in the 116 Discord and you want to join the listening party, you can join the listening party via that way by just like hovering over my name on the right side and do that.
So, a lot of people are gonna be upset with me. The chat's about to go off because I actually use Apple Music.
Oh, I don't have an issue either way. I just like Spotify. Discord and Spotify have integration.
Yeah, that's the only thing. So, a lot of people do get mad when I tell them that. I have all my playlists. I want to keep them. Or YouTube. YouTube's a decent choice. I use CDs. Desktop app integrates Apple Music to Discord. I'm gonna have to look into that. I'm gonna look into that later on.
All right. So whoever, do we have questions, etc.?
Anything else about polymorphism and inheritance? Because this can be a confusing topic at first.
It could be a confusing topic your whole life.
That too. It could be a very confusing topic for your whole life.
Polymorphism is a result of inheritance. Yes. Because classes can inherit each other, they can therefore be accessed via polymorphism. I'm waiting for Leo to recognize it.
I will.
It was too good not to put.
I have no words.
I know.
I have no words. I don't have any words, to be quite honest.
Alright, so do we have any generic conceptual questions that we can answer here? Because we're good at those.
We're really good at those.
Also, if you guys didn't realize, today we are doing something weird. We're streaming in full HD, which is not normal for us.
1080p.
1080p. Is it
60 frames a second?
No, I decided not to go up to 60. We're doing 30 right now.
Okay.
Is the imposter
sus? Yes.
Yes.
Always.
Always, yeah, literally always.
I'm the imposter.
Yep.
Always.
Mm-hmm.
I mean, look, my name is literally Leo, not Jacob.
Yeah, he's an imposter of Jacob.
There you have it, folks. Folks. I don't know.
Me using a 3080 just to play Among Us and Minecraft. I mean, don't at me like that.
Bold of you to assume I have the money for a 3080.
No, but like I use a 1080 Ti to like Counter-Strike and League. Me using a 30. Estate pattern.
Wait, hold on.
Yes.
Yes.
I don't know about Nazar's class.
Yeah.
Jesse's it definitely is. Actually, that's not true. I lied. Friday is state pattern, and then also next week.
I can actually check really quickly.
But yes, state pattern will be within the next. By the time we get to the next review session, you will have done some amount of state pattern because we're going to go over it in review session.
So state pattern is next week as well. So yes, we will go over state pattern.
Yeah, we're definitely going over state pattern. It's a good lecture. I think maybe I actually have no clue what the state pattern lecture looks like, to be honest.
I mean, at this point, I don't know if we're gonna have it.
Oh yeah. So it's a great lecture. I'm gonna, Leo, I'm
I hope
DMing
so.
you a screenshot of the first slide.
Okay, got it. What does the new keyword do? So new instantiates, basically the new keyword is used to instantiate an object of that type of class. So for example, if we wanted to create a new, for example, if we go back to our basketball class and we wanted to create an object of type basketball, we would need to say, we would need to have var a and then assign it type basketball, and it's equal to new, and new basically creates the basketball. So you would say new basketball. Elite TTV, glad to be hearing that.
Leo, go look at your Discord.
Definitely glad to be hearing that. I'm gonna look at it right now. Okay, good. We're not. That's a great first slide.
Yep.
I kind of like it actually.
What exactly does object-oriented programming mean? It means that we make classes and objects and stuff, and we program with them. Can we go over which part of the object are stored in stack and heap when an object is inherited? All of the object always is stored in the heap. That's the answer.
Yep. So whenever you create new classes and you try to create types of those classes, they're always stored in the heap. Always.
So the this keyword gets used within a class, and it refers to this current instantiation of the class, not the generic version of this class. So if I've got a basketball class, right, and I just say like I'm moving the variable, that'll move the variable for every class that's created after this point. But if I just say this dot variable and I move this variable, it means it'll just move this class, this instantiation of the class's variable. This refers to this exact reference that you're using, this exact variable. It doesn't refer to the generic version of it. Snazrin's lecture, she used a .use method and also put this in parentheses. I need some more context.
Yeah, I need to see the context of this because I did not watch that lecture.
If you can get me like a link to the slides, or Leo can get me a link to the slides, and you can sauce it to me.
If you could tell me which, if you could just tell me which
lecture,
which slides they're talking about, and which lecture you're talking about, I can definitely give that to Logan.
I need a PDF version, Leo, because I don't think I can access the UV lines.
That's fine. I'll figure it out.
Jesse also had that, but I realized that there was a method named DS. That's definitely possible.
Yes.
It's in the polymorphism slides.
That could be completely possible.
How much you want to bet Jesse and Nazrin's polymorphism slides is the same thing?
I'm about to say a little bit, but with some mixed differences.
Okay. It's the polymorphism lecture, by the way.
Yes. Okay. I'm gonna take a look. So that was today. Okay. Okay, let me just save this.
Slide 8 specifically.
I'm gonna send it to you right now.
Just send me a screenshot of slide 8. That would work too. However you want to do it. If you send me the PDF, I'll just open the whole PDF.
I got it.
The use method in the parent class during lecture did not have a block code attached to it. Is that normal for polymorphism? No, it's not normal for polymorphism, but it is normal for inheritance. When you inherit something, generally the part that you're inheriting isn't going to have... it's a method stub. It just says what it takes and what it returns, but it doesn't have any meat inside of it. All right, let's look
I
at
understand.
This.
I'm looking at it. Okay.
All right.
Let's talk about this.
Okay.
It's like the same idea of Jesse's.
Yeah. So we've got this. How do I zoom? There we go. This, I assume you mean ball.use parenthesis this. Ball is right here. We're going to assume that ball, probably from a prior slide, is a type that is an inanimate object. I'm going to assume that. I'm sure Leo can back me up on that. I'm sure everyone else in the chat can back me up on this. I'm going to assume that ball is an inanimate object. Since ball inherits an inanimate object, it has this this method use that takes a player. So in here, we're saying ball, which is this ball that's coming in here, dot use, we're using this method. This method takes a player as its parameter, and we're saying use this as in this instantiation of player that we're currently in, because we're in the class player. So we're talking about this current instantiation.
So Cyan Hawks, the use method in the parent class during lecture did not have a block of code attached to it. Is this normal for polymorphism? So these are just examples. So the abstract class use does not have any block of code for it because we want to usually override and define what we want use to do. However, in the class player, we're just not defining what use is going to be doing. We're just saying just use it. But we can add something to use if we wanted to. We could just say override define override define use, and then we can add some functionality to it.
Yeah, when you extend a class in IntelliJ and you have just like a method stuff like it here, like a method stub, that's what we call this, just the beginning part of the method with nothing behind it. When you have a method stuff like that, IntelliJ will actually like throw a big error that says you need to implement this method.
Yes. Whether it be in a extension of the class, the method will need to be implemented.
Is that only for method stubs? Yes. If you if you extend a class that has a stub in it, IntelliJ will yell at you to override that stub. If it's already a full method in a class that you're inheriting, it won't yell at you to override that. So it does, but it uses something, but nothing actually happens. You're correct. So the assumption here is that we see from turning this class up here into this class down here, is that ball.use, we'll assume that this inanimate object is actually going to be a ball. In the actual ball class, the use method would be instantiated with something. We can make a couple of assumptions from this. Can you point out exactly where polymorphism is being used on slides? Right here, where it says item is an inanimate object. Now, you can't make an instantiation of an inanimate object, but anything that extends an inanimate object that you've instantiated, you can put into this method and say, well, it's an inanimate object and it fits in here.
For example, let's say we had ball. Ball can also be of type inanimate object. So you can also put ball where it says it needs an inanimate object.
If a list has the same thing in different places of the list, how would you check the last one?
Do you mean the last element?
I think he means if you have a list that has 1, 2, 1, 3, 4, how would you find the second one, not the first one? The second instance of a given variable in a list, of a given value in a list. Or, well, not just specifically second, the last one.
I mean, you could
go through the list backwards. You reverse the list and start looping through the list.
Or you can go through a for loop and have an incrementer, and every time that specific element is you find it, you can save that index or replace it, either one.
Okay, what does the item.use of this do on that line? So that line, it says whatever this item is, whether it's a ball or whether it's like a mouse or a soda bottle or whatever this inanimate object is, it has a method called use, and it's going to do whatever that use method is to this player.
So in this case, use is not really doing much, but we can implement use ourselves, and we can say
in whatever the inanimated object class we implement used.
Right. So we can implement it ourselves and tell use what to do.
But basically, what all this is saying here, this inanimate object class is saying, is that every inanimate object has to have a use method. Which, so that way, when we're here and we say we have an inanimate object, we know that everyone has a use method, We just don't know exactly what that use method's doing, but it's going to do something because it exists. Polymorphism is basically when two classes exist and one extends the other. No, that's more towards inheritance. That's more towards inheritance, not polymorphism. Polymorphism says that you have a generic thing, and anything that falls under that generic thing can be classified as that generic thing. So if you have sports is your generic thing, and you've got basketball, baseball, football, and hockey, all of those can be still classified as sports. Okay, just to clarify, are these player classes extended from an inanimate object? No. Does it say anywhere that they're extended from an inanimate object? That didn't mean to come off like sounding like a dick. I legitimately, like, does it say anywhere that they're extended from an inanimate object?
There's no other way to say it. No, but...
Okay, then yeah, they're not...
You see the extend keyword.
Yeah, so then, no, they're not extended from an inanimate object. We can assume, because we're moving the ball class into here, because there's a use ball class, which does ball.use this, and there's a health potion class, which does potion.use of this, and both take in the same stuff and return the same stuff, that both, in this case, ball extends inanimate object, and health potion extends inanimate object. So that's why we can use them here in the item of inanimate object.
I'm going to try to find the specific slide.
Yeah, I was going to say, if you can send me another slide, that would be sick.
Okay, here's a good one. This one's for a health potion.
Got it. So as we can see here, health potion, right, is an inanimate object. And because it has an inanimate object, it means that somewhere at one point it has the method use, because we say that every class that extends inanimate object has to have a use version of it. So somewhere in here it would have use. I mean, like if we assign a variable of class 1 and assign it a class, if we assign a variable of type class 1 and assign it a class 2, so let's say class 2 extends class 1, so that'll work with no error. I think. Can you give me correctly? Yeah, if I understand this correctly, yes. Can you not use class 1 and class 2 and use like a real world example, and I'll tell you it'll work a little bit better. So the player class is separate from inanimate object, not a subclass. Correct. It's a totally separate thing. It's a totally separate thing. But this method in the player class, which is use item, takes in an inanimate object and uses whatever the use method in that inanimate object is, which can be different from each inanimate object, because an inanimate object is a abstract class. It means that any class that inherits inanimate object is a thing. Var variable class 1 equals new class 2 anything. That will work if class 2 inherits class 1. If class 2 extends class 1, that will work, yes.
Yes, that would work. We love silence. Silence is the
always best.
Does anybody have any more questions? Can you explain one more time when we have to define a class as an abstract class and when we don't?
So it's when you don't want to actually ever make that class. So let's go back to our inanimate object here. You never want to make it an inanimate object class. That's not specific enough for anything. There's no reason why you make an instantiation of an inanimate object. But you want these things that an inanimate object takes, this location, the velocity, the function object mass, the function use. You want all those things in every inanimate object you do make. So when you have a ball, which is an inanimate object, you want all those things to be in there. Abstract classes work as templates for other classes. That's the best way to explain it, is that an abstract class is a template for another class. So you define it as abstract when you don't want people to actually make it into an object. You just want it to be used to extend for another class, to be used as a template for something else.
Think of the abstract class as like a blueprint.
So was the
For other
ball
classes.
parent class used earlier in the session abstract class? Yep.
Yes, that one was an abstract class. That it was just unlucky that in these slides it's talked about as an extension, but in our example, the ball is a parent class.
Yep, it's a parent class, it's abstract, and these other classes extend ball.
Are there any questions about that? I would say. Feel free to ask your questions. That is exactly what we're here for.
That's correct. All good. I like all good. All good is good.
That's what we like. That's exactly what we want to hear.
You think you're good for now? Thank you.
That's what I like to hear.
I like to be thanked. So this is good.
I hope you came out of this knowing just a little bit more about polymorphism and inheritance than you originally
See you next
did.
week. Yeah.
Yeah.
See you next week is good.
Unless Logan stays on the phone for 3 hours with AT&T at this time, then it's a...
Please, not again. State pattern walkthrough. No. We haven't done state pattern in class yet on either class. We're gonna wait till next Wednesday when we have done state pattern in the classes to go through state patterns.
But the fact that you want to know about state pattern and that you're doing the lecture task, that's a good sign.
Okay, you understand the concepts a lot more? Good. You're a little confused on the coding? That's okay. You're going to need to go and do the lecture task or lecture question, depending on which class you're in, that refer to this, and you'll get a lot more better with the coding. We're here to help you with the concept of polymorphism and inheritance, and as long as we have gotten you guys to understand the concepts, then we've succeeded. Whether you guys think we succeeded or not, that's a separate matter, but we think we've succeeded. I know state pattern. I just want more examples. We're still not going over state pattern tonight. Next week, I don't have an issue going through it next week, but state patterns are a super complicated thing that I don't want to go through super early. Try working at LT4 and got lost. Yep, that's understandable. Again, would wait until next week.
Oh, LT4 state pattern as well?
Yeah, I think so.
Okay, definitely wait till next week. You're gonna love Jesse's slides on, I think it is state pattern.
State pattern's got a lot of Hulk in it.
Yeah, exactly.
LT4 is not state pattern. It's polymorphism. Oh.
Oh. We gotta get better at knowing our lecture tasks. Well, you.
Yeah.
You need.
I tried working at LT4 and got lost. Okay, so Jack Sparrow, here's what I recommend. I'd recommend try going through it now again, that you might understand polymorphism a little bit more. And if you still don't understand how it involves with your code, then go to an office hour, because I'm not gonna debug your code and that kind of stuff. Then homework 2 for Nazarene is also state pattern. Yeah, homework 2 for everybody is gonna be state pattern. Jesse's class has the point of sale system. Jesse's class has a point of sale system. Homework 2 for Nazarene is either calculator or microwave, both state patterns.
By the way, just to let everyone here know, the state pattern homework and the functional programming homework are two of my favorite homeworks.
Functional programming homework is great homework.
It's a great homework. You guys are gonna love it. So in other words, they are hard. Not necessarily.
The way that I like to describe homework 2, I haven't done point of sale. It's a new homework for this semester, but I've done both microwave and calculator. The way I like to describe both of them is that they're like mind teasers. They're not difficult. It's just like a teaser to wrap your head around, because it's so different than you normally code that it makes you think in different ways. Homework 3 is just straight difficult.
So I'm just gonna let you guys who are taking calculator and microwave know. So when I first took those two homeworks, I came from the same place that you guys came from, which is if else if and else statements. And I came into those homeworks and I completely lost my mind. I thought it was the coolest thing in the world.
Yeah, no, state machines are really, really cool. Yeah, no, I swear, we've been straight with you guys the entire semester. Homework 2 is not a difficult homework. It's a mind fuck. You got to wrap your head around it. And it's going to be a totally different way that you think of coding than you've ever thought of coding before. But it's not that difficult of a homework, to be honest. Leo, I don't think you found it that difficult either.
No, it was not.
It's just totally different way of that you've ever coded before that you have to wrap your head around.
Yeah,
genetic algorithm, homework 3, it's just straight hard. It's a really cool homework, but it's difficult. That one, that keeps me up at night still.
So, fun fact for everyone here, Gen Algo 3 was probably the homework I struggled with the most. So actually,
Same.
it's for both classes. I'm pretty sure.
As far as I know, Gen Algorithm will be coming back for Jesse's class and Nazaryn's class because we literally have petitioned Jesse to include genetic algorithm because we can't let him not run the course with it.
Gen Algo is probably one of the coolest assignments ever. I remember when I took it, it was so cool. But I'm not gonna lie to you guys. Gen Algo also takes a long time to wrap your head around.
Why do you hate us?
I'll tell you that much.
Well, first of all, I hate you guys because I do, and also if I did genetic algorithm 2.5 years ago when I took this class, you guys should be forced to do it too. No, it's just genetic algorithm is a really, really good assignment that teaches you a lot about functional programming, which is what we'll go over then, and it's a really important assignment, and also like it's one of the coolest assignments we do, other than Towers 2.
I can give you a guarantee that after functional programming, you guys are going to be better programmers.
Correct.
A guarantee on that.
And you'll hate using Python for like a solid 3 months.
Yes.
Because you can't really do the same level of functional programming in Python. And then you'll go back and you'll realize, oh, I do different things in Python than I do in a functional programming language. And oh, wait, I can actually do a little bit of functional programming in Python with Lambda functions. But like, it'll be a different kind of thing. All right. Since we're only talking about the future and what the next kind of stuff holds, we're actually going to get going. We will see you guys next week, same time. We're probably going to go all 2 hours next week because state pattern's a super long topic for us to discuss, and we have to continuously discuss how it shows polymorphism and inheritance, but how it is not the definition of either polymorphism or inheritance. So
right,
we'll get on to that next week with you guys. Have a nice weekend. For Nazaryn's class, I believe you guys have stuff due Friday.
Yes.
So you guys
get
have
on your lecture questions.
You guys have your lecture questions and your rhyming dictionary physics engine due Friday. Jesse's class, you guys should start getting started on your point of sale stuff, regardless of whether you can do the state pattern, that kind of stuff. There's a bunch of lecture tests that you can do right now. That's it. We'll see you guys next week.